Alright, now it's time for ITTOs. Let's start with the inputs. First, project management plan. There are two components in it. Let's look at them. The first is schedule management plan. The schedule management plan contains schedule creation method and tools along with how the schedule to be calculated. So naturally it becomes an input. The next component of project management plan is scope baseline, scope statement, WBS, and WBS dictionary combined together called as scope baseline contains details about project deliverables, so they are considered as inputs. The next input is project documents. There are few in it. Let's look at them one by one. Activity attributes. While developing project schedule, the activity attributes such as activity list, predecessor, successor, activity duration, and resource requirements will be helpful, so they become part of input. Activity list. To develop the project schedule, obviously you should know the activities that are to be carried out in the project. Those activities can be found in activity list. The next one is assumption log. Assumptions and constraints are recorded in the assumption log. They will contain details of individual project risks that may impact the project schedule. So they also become part of input. The next one is basis of estimates. The numbers from basis of estimates from the basis to do the estimation. So normally they become input to develop schedule. Duration estimates. Duration estimate contains the number of work period required to complete an activity. Lessons learned register. Lessons learned from previous projects regarding developing the schedule model can be applied to improve the validity of schedule model. Milestone list. Why milestone list? Because the milestone list has schedule dates for specific milestones. So naturally they become input. The next one is project schedule network diagram. I hope you remember this picture. A quick recap about project schedule network diagram. A project schedule network diagram is a graphical representation of the logical relationship, also referred as dependencies, among the project schedule activities. A project schedule network diagram is produced manually or by using project management software. It can also include full project details or can have one or more project summary activities. Alright, the next one is the project team assignments. The project team assignments specify which resources are assigned to different project activity. Resource calendars. The resource calendar contains information on the availability of resources during the project period, of course, specific to those activities. The next one is resource requirements. To develop schedule, you need to have the type and quantities of resources required for each activity. The last one in the project document is risk register. The risk register provides the details of all the identified risks and their characteristics which can affect the schedule. So you need a risk register as an input. The next input is agreements. Agreements will have deliverable milestone from the vendor. Of course, these inputs will be helpful to develop the schedule that are relevant to external activities managed by suppliers and vendors. The next input in the list is enterprise environmental factors. Let's look at the elements of enterprise environmental factors that are used as inputs. First, communication channels. Government or industry standards such as regulations, product standards, and codes of conduct. The last input for this process develop schedule is organizational process asserts. Project calendars, scheduling methodology containing policies, governing schedule model, development, and maintenance are the two key elements that are used from organizational process asserts. Let's look at the tools and techniques. The first one is schedule network analysis. Schedule network analysis is a technique that is used to generate the project schedule model. It employs several other techniques such as critical path method, resource optimization technique, and modeling techniques. Additionally, we already discussed that whenever there is a path convergence, the project risk increases. So this helps to understand the schedule reserves. Of course, it's an iterative process. So until a viable schedule model is developed, this process gets repeated. The next is critical path method. We already had a detailed discussion about it, so let's jump into the context. To develop an optimal schedule with the given constraints and assumptions, the critical path method is used. The next tools and technique is resource optimization. Let's start with the overview. Resource optimization is used to adjust the start and finish date of activities to adjust planned resources to be equal or less than resource availability. Example of resource optimization techniques that can be used to adjust the schedule model due to demand and supply of resources can be resource leveling and resource smoothing. Let's talk about it. Let's understand about resource leveling and resource smoothing. In every organization, resources are limited. Let it be men, machine, or material. Due to the limited availability of the resources, you may not be able to deploy more number of resources to an activity to complete it sooner. You may have to adjust the activity start date. As a result, naturally, the project end date also gets shifted. Let's look at an example to understand them easily. Let's say you have a work package that should be completed in 5 days, and you have Peter, the developer. To complete all the activities in 5 days, Peter has to work more than 8 hours in a day. In some days, for 16 hours, which is not possible. So, you have to take it off. Let's see how to address it using resource leveling. In resource leveling, you level the hours and distribute it in such a way that Peter does not work more than 8 hours a day. So, here you have leveled the utilization of Peter. Also, as you can notice, Peter not only works for more than 8 hours, but also he works less than 8 hours in some days. Here, the resource utilization is not evenly distributed. Even though the work package has to be completed within 5 days, you have to do resource leveling because of the fact that you cannot use the resource for more than 8 hours in a day. Also, as you have noticed, without leveling of resources, the work package duration was 5 days. Now, after leveling the resources, the work package duration is 10 days. Okay, here you have solved the problem of overutilizing Peter and leveled him less than 8 hours. But the utilization is quite uneven. On some days, he works for 8 hours. On some of the days, he works for 5 hours, and few days, he works for 4 hours. Will it not be nice if his utilization is smooth end, meaning utilizing him more or less 8 hours in a day? That's when the resource leveling comes into picture. As you could see in the diagram, the utilization of Peter is now smoothened. How was it done? His utilization is balanced by looking at other activities. As a result, he is utilized 8 hours in most of the days and 7 hours in some of the days, which is still okay. Please note that it is not possible to achieve resource smoothing for every single work package. It is more of a nice to have feature. If possible, we can smooth the utilization, but it is not necessary that it must be done. It all depends on the project constraints. Sometimes there is no way you can smooth the resource utilization. In those cases, you have to leave it as it is. But the resource leveling must be done because you are overutilizing the resources. The next is data analysis. Here we have what if scenario analysis and simulation. Let's look at what if scenario analysis. What if scenario analysis asks the questions, what if scenario X happens? For example, what will happen if one of the key project resource leaves the project? What will happen if the project fund is not available on time? What if supplier fails to meet quality requirements? So on and so forth. So this process evaluates various scenarios in order to predict their effect, both positive and negative, on project deliverables. Now, what if scenario in current context? Schedule network analysis is performed to compute different scenarios, for example, by delaying major component delivery, introducing external factors, and see their effect on the project deliverables. In develop schedule, this is done to assess the feasibility of the project schedule at different scenarios. This will help the project manager to get prepared with the response plans to address the impact when the situation occurs. The next data analysis technique is simulation. A simulation is an animated model that mimics the operation of an existing or proposed system. You have multiple work packages along with the duration on one side and on the other side, you have different set of assumptions, constraints, risks, and issues. You combine them together to simulate the scenario. Probability distribution, which is a pictorial representation, can help to show the certainty or uncertainty. Let's look at the figure 6.18 from PMBOK guide from page number 218, and in soft copy, it's in page number 252. In this example, there is a 10% probability that the project will finish on or before the target date of May 13, while there is a 90% probability of completing the project by May 28th. One of the most common simulation technique is Monte Carlo analysis. Let's discuss about it. This technique uses computer software to simulate the outcome of a project based on 3-point estimates: optimistic, pessimistic, and most likely, and I hope you remember it, for each activity and the network diagram. The simulation can tell you the probability of completing the project on specific day, the probability of completing the project at specific cost, the probability of any activity being on the critical path, and also an indication of overall project risk. As mentioned earlier, to do Monte Carlo analysis, you need computer and the experts because they are quite complex analysis. Alright, now the next one is leads and lags. We already discussed about it, so let's have a quick recall. Lead is something which goes in advance than the normal, like a leader. Lag is something which is delayed, which means after the completion of predecessor activity, the next activity cannot be started immediately. The successor activity has to wait for a certain period of time. Now, lead and lag in current context. Here, leads and lags are applied during network analysis. This helps to develop a viable schedule by adjusting the start date of successor activities. To put it in simple words, leads can be used to advance successor activity with respect to the predecessor activity. Lags are used when lapse time is required. Now, let's talk about the next in the list, which is schedule compression. Let's say the project is not progressing as per the plan. The first reaction from most of us would be add more resources, isn't it? So, this technique of adding more resources to complete the project is called as crashing. Is there any other way? Make a guess. Let me help you. Okay, let's go back to our construction example. Let's say you prepared the land and it's ready to start the construction. Now it's time to do the architectural drawing, including the interiors. Of course, it's logical too. Before starting the construction, you should know how the end product should look like, right? But the rainy season is coming. You decided to continue the construction and try to progress as much as possible so that before rain comes in, you would have completed majority of the key activities. So, you started the construction with the blueprint drawing. In parallel to that, you start working on making the architectural drawing, including the interior. Here, you carried out both construction and architectural drawing in parallel. This is called fast tracking. Let's look at the picture 6.19 from PMBOK guide. On the top, as you could see, the work will take 15 units of time to complete on a normal track. But by adding more resources, you can complete the work in 10 units of time. As you know, adding more resources will add cost to the project. You may have to pay for overtime or even additional payment to speed up the deliverables. By the way, ensure that you do crashing only for the activities that is in the critical path. It's common sense, isn't it? Who wants to complete the activities faster when it is not in the critical path? Okay, the next one, the bottom picture represents fast tracking where you do things in parallel. Of course, fast tracking adds more risks. Let's go back to the construction example. The ideal way could have been architectural drawing first, then start the construction. But you already have the blueprint ready for the structure. So based on the blueprint, you can start making the construction without worrying much about the aesthetic part, which is the elevation of the drawing. By doing the things in parallel, the project progress can be faster, but you add risk to the project. In case, if any major changes to be done in the construction to match with the aesthetic part of the building, then you may end up in doing rework. It could be small or it could be big. It completely depends on the architectural drawing. But you already took the risk and proceeded. Here, you achieved time but added risk. So these schedule compression techniques are used to shorten the project duration without reducing the scope. Obviously, they are done to meet the schedule imposed due date or milestones. The next in the list is Project Management Information System. Here we are in develop schedule. So the project management information system is scheduling software that speed up the process of building schedule model by generating start and finish date based on the inputs of activities, network diagrams, resources, and activity duration. Let's look at the next tools and technique, Agile Release Planning. Let's start with the overview. Agile Release Planning provides a high-level summary timeline. This timeline will constrain the release schedule of typically 3 to 6 weeks. But again, this is completely depends on the project and also product roadmap and the product vision. Agile release planning also determines the number of iterations or sprints in the release. This allows the product owner and team to decide the level of scope development and how long it will take for a releasable product. Business goals, dependencies, and impediments are some of the influences. In fact, agile timelines are easy to understand. They provide feature versus number of iterations needed. This gives a good idea to the customer or client on how long each release would take. The picture shows the relationship among the product vision, product roadmap, release planning, and iteration planning. This picture is from PMBOK figure number 6.20. Now in context. Using the agile release planning, you can develop schedule process as it suits to the phase release of the product. Let's talk about the outputs. First, schedule baseline. A schedule baseline is the approved version of schedule model. The start and the end date of every project activities are baselined. The moment I say approved version, then I think you know these baselines can be changed only through formal change control procedures. This baseline schedule is used as a basis for comparison to actual results. The schedule baseline is a component of project management plan. This is accepted and approved by the appropriate stakeholders. During monitoring and controlling, the approved baseline dates are compared to the actual start and finish dates to determine if variants have occurred. Meeting the schedule baseline is one of the measures of project success. The second output is project schedule. Of course, project schedule links the activities with planned dates, duration, and resources. If the resources are pre-assigned, then the project schedule will have the information about it. Project schedule can be presented in various formats such as tabular form, bar chart, milestone, and project schedule network diagram, etc. Let's have a quick look at them. First, bar charts. Bar charts are relatively easy to read and understand, and of course, they are most commonly used. Bar chart are also known as Gantt chart. The Gantt charts are quite similar to the bar charts. The bar chart represents schedule information where activities are listed on the vertical axis, dates are shown on the horizontal axis, and activity duration are shown in horizontal bars placed according to the start and finish dates. Depending on the audience, float can be depicted. By the way, this picture is from PMBOK Guide figure 6.21 where schedule is presented in WABS structure format. The next one is milestone chart. These charts are similar to bar charts. Here, the schedule start and completion or any other major deliverables are presented. The next one is project schedule network diagram. Here we have activity on node diagram. This diagram shows the activities and relationship without a time scale. Sometimes this is also referred as pure logic diagram. It can be presented in time scale schedule network diagram format, which is sometimes called as logic bar chart. In these diagrams, the activities are presented with date, network logic, and project's critical path. This helps to understand how each work package is planned as a series of related activities. The next one is timescale logic diagram. These diagrams include timescale and bars that represents the duration of activities with the logical relationship. They are optimized to show the relationship between activities where any number of activities may appear on the same line of diagram in sequence. The next output is schedule data. Let's start with the overview about schedule data. Schedule data is a collection of information related to project schedules such as schedule activities, activity attributes, schedule milestone, assumptions and constraints related to schedule. There may be additional data related to schedule. It's completely dependent on the type of project and the application area. Now, in current context, as an output of developed schedule, the schedule data can have information such as project activity related information, for example, project activities, activity attributes, duration estimates, dependencies, milestones, assumptions, and constraints that are used in creating the schedule. Applied schedule resource, alternative schedules such as best case, worst case, with resource leveling, without resource leveling, with imposed date, without imposed date, etc. Resource information related to schedules such as resource requirements by time period, typically in the form of resource histogram. The fourth output is project calendars. Let's look at the overview. Project calendars indicate the working days and shifts. Here in developed schedule, the project calendar to be updated upon completing developed schedule. The fifth output is change requests. Here, modification to the project scope or project schedule may result in change requests to the scope baseline and or other components of the project management plan. Change requests are processed through change control process. The sixth output is project management plan updates. Obviously, here we are talking about the components of project management plan. There are two in it. Let's look at them. First one is schedule management plan. The schedule management plan updated to reflect changes in the way the schedule was developed and the way the schedule will be managed. The next one is cost baseline. Changes to the cost baseline are incorporated in response to approved changes in scope, resource, or cost estimates. In some cases, cost variance can be so severe that demands a revised cost baseline to provide a realistic basis for performance measurements. The last output is project documents updates. There are 6 in it. Let's look at them. First, activity attributes. Once the schedule is developed, the activity attributes such as a revised resource requirements, precedence activities, successor activities, and other relevant information will be generated or they get updated. Assumption log. You might have made many assumptions during schedule development. All those should be documented. It includes information related to duration, resources, resource utilization, activity sequencing, and other information related to schedule model. The third project documents to be updated is duration estimates. Upon completing the developed schedule, you have information on activity dependencies, availability of resources. The difference between planned versus actual can result in change to duration estimates. The fourth one is lessons learned. The lessons learned register can be updated with techniques that were efficient and effective in developing the schedule model. The next one is resource requirements. When the resource requirements changes, those changes need to be updated in resource requirements. Techniques such as resource leveling, resource smoothing, fast tracking may have significant effect on primary estimation. The final one is risk register. The perceived opportunities or threat through the scheduling assumptions are updated in risk register. All right, that wraps up the ITTOs of develop schedule. Let's move to the next process.